power goes out during a blizzard, your furnace dies. Within 3 hours, your house drops below freezing. The pipes are next. But there was a structure that worked the opposite way. One that got warmer as the storm intensified, ran without electricity, and couldn't fail even if you wanted it to. It was called a byre dwelling, and its furnace was alive. 10 cows, standing in stalls under the same roof where a family slept, radiated 10,000 watts of body heat through a timber wall. The system had no moving parts, no fuel line, no thermostat. It was a biological machine, and it kept Northern European families warm through centuries of winters that would cripple a modern suburb in days. This wasn't desperation, it was engineering. Winter in medieval Europe was not an inconvenience, it was an adversary. Firewood was the primary defense, but it was never abundant. A single winter's supply required months of labor: felling, hauling, splitting, seasoning. In many regions, wood was a managed resource, and forests were not infinite. A central hearth could heat the air immediately around it, but a large, uninsulated space bled warmth as fast as the fire could produce it. The battle was not to generate heat, but to hold on to it. The animals made that battle existential. A family's cattle were not livestock in the modern sense. They were capital. A single ox pulled the plow that fed the household. A cow provided milk, calves, and labor. Losing one to cold, illness, or predators meant losing the ability to work the land. It meant hunger. In some cases, it meant eviction. Protecting those animals was not about affection. It was about survival in the most literal sense. The solution was not to build two structures, one for people, one for animals. The solution was to stop thinking of them as separate problems. The Longhouse emerged because medieval builders understood something modern architecture has forgotten. Heat is a byproduct of life, and if you design the structure correctly, that byproduct becomes the system. The byre dwelling was a single rectangular structure, typically 50 to 80 feet long, divided internally into two zones under one continuous roof. The human living quarters occupied one end. The animal stalls occupied the other. There was no separate barn. There was no hallway connecting two buildings. The cow stood 15 feet from where the family slept, separated only by a timber partition. This was not a compromise. It was a deliberate thermal strategy, refined across centuries and replicated from Scandinavia to the Netherlands. The structure appeared in the archaeological record as early as the Iron Age and remained common through the High Middle Ages. Regional variations existed. Some had stone walls, others used wattle and daub. Some placed animals on the north end to block prevailing winds, but the core principle never changed. The animals were not stored near the house, they were integrated into it. The roof was the key. A single sloped plane covered both zones, creating a shared thermal envelope. Warm air generated in the byre rose naturally and collected along the underside of the thatch. That air had nowhere to go but toward the human quarters. The ceiling acted as a passive duct, channeling heat from one end of the structure to the other without pumps, fans, or fuel. The partition between the two zones was not airtight. It was built from vertical planks or woven panels, materials that allowed airflow while blocking direct drafts at floor level. The wall was porous by design. Warm air passed through the gaps near the ceiling. Cold air at ground level stayed trapped in the byre where the animals' bodies displaced it. The temperature gradient did the work. Physics, not labor. The floor plan reinforced the system. The byre was sunken, dug down a foot or more below the main living platform. Gravity pulled waste and cold air downward. The human quarters sat elevated on packed earth or timber, keeping feet dry and bodies above the coldest layer of air. That height difference was not about status. It was about thermodynamics. Cold air is heavy. Let it pool where the heat source can displace it. Beneath the animals, the floor was not cleaned daily. Straw bedding was laid down in thick layers and left to accumulate through the winter. Manure mixed with the straw. The pack compressed under the weight of the animals. Decomposition began. That decomposition was exothermic. It released heat. Not dramatic heat, but steady, low-grade warmth rising from below, adding to the radiant output of the animals themselves. The floor became a second furnace. The system was self-regulating. The colder the outside air, the more the animals ate. The more they ate, the more heat they produced. The household did not adjust a dial. The biology adjusted itself. Feed them, and the furnace stayed on. The fuel was hay, stored in the same structure, grown in the surrounding fields. No supply chain, no external dependency. The system was closed. A cow at rest produces approximately 1,000 watts of thermal energy. This is not an estimate. It is a measured output cited in modern agricultural ventilation standards derived from the animal's basal metabolic rate. A cow is not passive mass. It is a furnace running on cellulose, and it never shuts off. 10 cows produce 10,000 watts. That is 10 electric space heaters running continuously without drawing a single amp from the grid. In the confined space of the byre, that heat did not dissipate into open air. It accumulated. The animals stood shoulder to shoulder in stalls along one side of the structure, their bodies forming a radiant wall. The air around them warmed first, then the surfaces, then the volume. Warm air is lighter than cold air. It rose. The sloped roof trapped it. The ceiling was not vaulted or peaked with open gables. It was a single angled plane, sealed with thatch, running the full length of the building. The rising heat from the byre had only one direction to travel, along that slope, toward the human quarters. The timber partition separating the two zones was not a thermal barrier. It was a filter. The gaps between the planks, the porous nature of wattle and daub, the deliberate absence of mortar or sealant, all of it allowed warm air to pass through at ceiling height while blocking floor-level drafts and odors. The wall functioned as a radiator. Warm air gathered against it on the animal side, transferred heat through the wood, and bled through the gaps into the living space. The family did not need to open a door or tend a vent. The heat came to them. The deep litter system on the byre floor contributed a second thermal layer. Straw bedding was not removed, it was added to. Over weeks, the pack grew thicker, 6 inches, then 12, then 18. Manure mixed with the straw. Moisture from urine activated microbial breakdown. The composting mass released heat. Not dramatic heat, but constant low-grade warmth rising from below, the way a compost pile steams in winter air. The animals stood on a heated floor. The heat radiated upward into their bodies, into the air, into the structure itself. The result was not a single uniform temperature. It was a gradient. The byre remained the warmest zone, often reaching 50 to 55 degrees Fahrenheit, even when the outside air dropped below zero. The living quarters, receiving the convected and radiant heat from the partition and ceiling, maintained a temperature 10 to 15 degrees cooler than the byre, but still 30 to 40 degrees warmer than the outside. Add the central hearth, the body heat of the family, and the insulation of woolen clothing and bedding, and portions of the living space could absolutely reach 65 degrees. This was not theoretical. It was thermal physics applied through architecture. The medieval builder did not need to understand convection in abstract terms. They observed that heat rises, that animals produce warmth, that wood transfers temperature, and that a sloped roof traps air. They built the structure to cooperate with those realities. The system required no maintenance beyond feeding the animals and adding straw. It had no ignition source to fail, no ductwork to clog, no blower motor to burn out. The furnace was biological. As long as the cows were alive, the heat was on. The human quarters sat on a raised platform, elevated above the sunken byre by a foot or more of packed earth or timber framing. This was not decoration. It was drainage, thermal zoning, and hygiene built into the floor plan. Gravity pulled waste downward into the animal channel. Cold air pooled at the lowest point, where the cattle's body heat could displace it. The family lived above that layer, feet dry, bodies positioned in the warmer stratum of air that rose from below and flowed in from the partition. The smell was not what modern assumptions expect. The byre was not a cesspool. It was a managed system. The deep litter absorbed liquid waste. The straw composted slowly, breaking down odor compounds rather than amplifying them. Ventilation gaps near the roofline allowed moisture and ammonia to escape without bleeding away heat. What remained was the scent of hay, warm animals, and wood smoke, earthy, organic, but not foul. To the family living there, it was the smell of security. It meant the cattle were healthy, it meant the system was functioning. It meant winter had not yet won. The sounds were constant but low. The shuffling of hooves on straw, the rhythmic chewing of cud, the occasional low from a cow shifting position. These were not disturbances. They were confirmation. Every sound was proof that the wealth of the household was alive, sheltered, and safe on the other side of the wall. Silence would have been the danger. Silence meant something had gone wrong. Smoke from the central hearth did not simply vent out through a hole in the roof. It filled the upper volume of the living space, lingering in the rafters before gradually seeping through gaps in the thatch. This was intentional. The smoke cured meat hanging from the beams. It coated the underside of the thatch with creosote, waterproofing the fibers and extending the roof's lifespan. It killed insects, larvae, and rot. The hearth was not just a heat source. It was a preservation system, a pest control mechanism, and a structural treatment tool. One fire served 5 functions. The partition wall was within arm's reach during daily life. It was not a barrier to avoid, it was a surface to use. In some longhouses, pegs were driven into the timber to hang tools, clothing, or drying herbs. The warmth radiating through the wood made it an ideal spot to dry wet garments or warm a blanket before sleep. The wall was not separating 2 worlds, it was connecting them. The animal side fed heat into the human side, and the human side benefited from proximity without sacrificing livability. At night, the family slept in the warmest part of the structure, farthest from the door, closest to the partition, on raised sleeping platforms layered with straw mattresses and woolen blankets. The heat from the byre radiated through the wall. The heat from the banked hearth glowed low. The body heat of 6 or 8 people sharing a confined space added another thermal layer. The combined effect was a microclimate that could remain 40 degrees warmer than the air outside, sustained without active labor, without fuel consumption beyond the animal's hay, and without any vulnerability to external infrastructure. This was not endurance, it was system design. The Longhouse did not ask its occupants to suffer the cold. It eliminated the cold as a threat by making the architecture itself a participant in thermal regulation. The house was not heated, the house was the heater. A modern furnace fails when the grid goes down. It fails when the gas line freezes. It fails when the thermostat loses power, when the igniter burns out, when the blower motor seizes. Every component is a vulnerability. The system depends on infrastructure that extends miles beyond the building it serves: power plants, fuel depots, supply lines, repair networks. When the blizzard hits hard enough to sever those connections, the furnace becomes inert metal in the basement. The byre dwelling had no external dependencies. The fuel was hay, harvested in summer and stored in the loft above the animal stalls or in ricks outside the door. The furnace was 10 cows, standing in place, converting that hay into body heat at a fixed rate determined by biology, not mechanics. There was no ignition sequence to fail, no pilot light to extinguish, no circuit board to short out. The system ran on digestion, and digestion does not stop because the wind is howling. The blizzard that kills a modern heating system was precisely the condition this architecture was built to withstand. External temperature drops, snow piles against the walls. Wind drives cold air through every crack in the building envelope. But inside the byre, nothing changes. The cows eat. Their metabolic rate increases slightly in response to the cold, producing more heat. The deep litter continues composting, adding its low-grade warmth from below. The sloped roof traps the rising air. The partition radiates heat into the living quarters. The system does not struggle. It simply continues, indifferent to the chaos outside. The resilience was not accidental. It was the result of eliminating failure points. The Longhouse required no fuel that had to be delivered, no equipment that could break, no expertise to repair a malfunction. The household maintained the system by performing the same tasks they would have done regardless: feeding the animals, adding bedding, tending the fire. The heating was not a separate operation. It was embedded in the labor of survival itself. The sustainability was absolute. The sun grew the grass, the cattle ate the grass and produced heat, milk, labor, and manure. The manure fertilized the fields to grow more grass. The cycle was closed. There were no extractive inputs, no fossil carbon, no waste stream that required disposal. The system was a loop, powered entirely by solar energy stored in plant matter and converted through biology into the warmth that kept a family alive. Modern heating is a declaration of war against winter. It burns fuel to generate warmth, fighting a continuous battle against the cold that seeps back in the moment the furnace cycles off. The Longhouse did not fight. It co-opted. It took a biological process that was happening anyway, animals generating body heat, and channeled it through architecture into human comfort. The animals needed to be fed whether they lived in a separate barn or under the same roof. By integrating them into the thermal envelope, the structure made their heat a resource instead of waste. When the blizzard passed and the snow finally stopped, the modern house would remain cold until the power returned, until the repair crew arrived, until the system was restored by forces outside the household's control. The Longhouse required nothing. The cows were still standing. The warmth was still radiating through the partition. The family had never stopped being warm. That difference is the measure of what was lost. The Buyer dwelling solved 3 survival problems with a single structure. It sheltered the animals that represented the family's entire economic future. It created a living space protected from predators and weather. And it produced reliable warmth without consuming firewood, without requiring constant labor, and without any possibility of mechanical failure. The design used local timber, stone, thatch, and earth. Nothing had to be imported. Nothing had to be manufactured. The most sophisticated component was biology itself. This was not primitive improvisation. It was thermal engineering that worked with natural processes instead of overpowering them. Modern heating treats the cold as an enemy to defeat with brute force, burning fuel to create warmth that immediately begins leaking back out through walls, windows, and roofs. The Longhouse treated animal metabolism as an asset to capture. The architecture became a passive heat exchanger, channeling biological output into human comfort through convection, radiation, and gravity. No pumps, no fans, no control systems. Just geometry and materials arranged to cooperate with physics. What was lost in the transition to modernity was not comfort, it was resilience. The Longhouse could not fail in the ways a furnace fails because it had no ignition to extinguish, no fuel line to freeze, no grid to collapse. The system ran on hay grown within sight of the door and converted by animals that were already being fed. The blizzard that shuts down a modern suburb would not have registered as a crisis inside that structure. The cows would keep eating, the heat would keep rising, the family would remain warm. We gained thermostats, push-button ignition, and the ability to set a house to exactly 72 degrees without thinking about fuel. But we gave up autonomy. We gave up closed-loop sustainability. We gave up the knowledge that a building could be designed to generate its own warmth by aligning human needs with biological realities. The Longhouse stands in the archaeological record as evidence that the most powerful solutions are not always the most complex. Sometimes they are simply the ones that remain alive.